Good morning. This is a video where a user has some data and he wants to spread it using a Walsh code. Are you ready? So what we have user number 1, and the user number 1 has some data. So those are 2 bits that the user wants to send, and the user is also going to spread the signal, and the user is going to spread that signal with a Walsh code, and that's the Walsh code they're going to use. So we start with the code, and you apply the code to the first bit. So the first bit is this one. So you put the data here. The first bit is a 0, so you just repeat it like that. Then you apply the code again to the next bit, like that. And then you use the exclusive OR. And what is exclusive OR? It's when they're the same, you get 0, and when they're different, you get 1. So these are the same, you get 0, different, you get 1, 0, 1, and same is 0, different is 1, like that. So then you can say that user number 1 has a spread message that looks like this. So the data itself is 2 bits, and the spread message is 1, 2, 3, 4, 5, 6, 7, 8 chips. Good morning. So we've already spread user 1's data, and now we're going to do the same with user number 2. So we have user number 2. And user number 2 has some data. The data, 2 bits, 1 and 0. And user number 2 has a spreading code as well. So we're going to spread user number 2's data the same way we did with user number 1, except the data is different and the code is different. So, spread the signal. We start with the code and the data. So the code is 0, 0, 1, 1, and the first bit is 1. So we put the data like that. The first bit is 1. And then we do the code again, same code, second bit is 0. And then we again do the XOR, different is 1, same is 0, so different is 1, 1, these are the same, same is 0, different is 1. So then we have user number 2, spread message, which works out to be 1, 1, 0, 0, 0, 0, 1, 1. And just like the first time, we started out with 2 bits, and we end up with 1, 2, 3, 4, 5, 6, 7, 8 chips. Good morning. So now we have we've already spread user 1's data and user 2's data. We're going to do that with number 3. So we have user number 3. The data is 1, 1. And user number 3 also has spreading code, which is different from the rest of them. Each user has a unique code, and each user has its own data. Then we will spread the signal. The code and the data, just like before. So the code here is we go. The data is, the first bit goes here, the second bit goes here, OR, and we know that if it's different, it's 1. If it's the same, it's 0 in all of these cases. We end up with that. So then we have user number 3, spread message looks like this. So just like before, we started with 2 bits, and now we have 8 chips. Okay, so we have 3 users, and each user has its own data, and each user signal has been spread with a unique code. So now we want to combine all 3 signals. And the way that we're going to do that is we're going to create waveforms. So how we're going to do that? Well, I've decided that I want to represent a 0 bit as +1 volts, and I want to represent a 1 bit as -1 volts. So that's what I've decided to do. So watch this. So I've got here user 1, and that's the spread signal, 8 chips. User 2, spread signal, 8 chips. User 3, spread signal, 8 chips. So this is what we came up with in the last few videos when we took the data and spread it. So now, waveform, I'm going to say this is +1 volt, this is -1, and what did I say? I said a 0 is +1, so I'm going to go like this. That's 0, that's a 1, that's a 0, that's a 1, that's a 0, 1, 0, 1. So that's user 1. User 2, if that's +1 and that's -1, then a 1, that's -1, so we'll go like that. Like that. And user 3, well, this one will be easy, +1 and -1. So 1 bit is -1 volts. So I have 3 unique waveforms which represents the spread signal. That's what we've got so far. Okay, so we have user 1, user 2, user 3. We've created waveforms which represents each user. But if we had all of these users using the same frequency at the same time, then the resulting signal would actually be this signal added to this signal added to this signal. So that's what we'll do. So what do we got here? We've got +1, -1, and -1. What's 1 minus 1 minus 1? That'd be -1, I think. Okay, so then we have a -1 and a -1 and a -1. That sounds like -3 to me. +1 plus 1, that's 2. 2 minus 1 is 1. And -1 plus 1 minus 1 works out to -1. So this one is +1 plus 1 minus 1. That's 1. And then we have -1 plus 1 minus 1. Turns out to -1 plus 1 minus 1 minus 1. And -1 minus 1 minus 1, that works out to -3. So if we wanted to create a composite waveform, so this would be the waveform that every single user receives. So if we have, let's say, 3 volts, 2 volts, 1, 0, -1. So this is just so 0 would be here. I'm going to represent this -1. Here's -1. And then -3. I know you can't see that. There. And this is up to 1. And down to -1. Back up to 1. -1. -1. And -3. So this here is if we took each individual user's signal, converted it to a waveform, added them all together, So every user's signal is here. So every receiver is going to receive every receiver is going to receive the composite signal. Okay, this is the best part. Are you ready? So this is user 1. User 1 is we have the data and the spreading code, and the signal has been spread and then combined with the signal from 2 other users. So we have a composite waveform which contains 3 users worth of data. Contains 3 users data. So what we're going to do is we're going to take the user 1 code, and what is that code? Let's look it up. We use the code 0101. So if we convert that to a waveform, the 0 bit was represented as +1 volts, and the 1 bit was represented as -1. So this would be +1 volts, and these ones are -1 volt. So 0101 would look like +1, -1, like that. 0, 1, 0, 1, and we apply the code again. 0, 1, 0, 1. So this is the magical part. Then we multiply them. So we have -1 times +1, we end up with -1. We have -3 times -1, we end up with +3. We have 1 times 1, 1. Then we have -1 times -1 is 1. So then we go, what does that work out to be? -1 plus 3 plus 1 plus 1 equals 4. But this is occurring 1, 2, 3, 4 times, so we average that out. It works out to be 1. Okay, so now we'll just try this one. +1 times +1, 1. -1 times -1, 1. -1 times +1, -1. -3 times -1 is 3. So what do we got here? We've got 1 plus 1 is 2, minus 1 is 1, plus 3 is 4. That's 4, but then 4 is occurring across, so we're dividing it by 4 equals 1. So we have a +1 and a +1, but this is really 1 volt. +1 volt represents a 0 bit, and +1 represents a 0 bit, which, if I show you the original thing that we looked at, remember this? User 1's original data, 0 and 0. So you see what happened was, user 1 spread the signal with a spreading code, user 2 did the same, user 3 did the same, all those 3 signals were added together, then we applied user 1's code to that composite signal, and magically the original data was recovered, 0 and 0. So now you can try it for user 2 and 3, and hopefully you will find that the same thing happens.